asked to find out the number of integral solutions of modulus of p plus modulus of q is less than 41. Now because of modulus, this question becomes slightly complicated, because if it was a simple question such that a plus b is less than 41 and both say a and b are non-negative integers, this becomes a very straightforward question. So what we'll do is we'll first try to understand how a plus b, where a and b are non-negative integers, less than 41 will be calculated, the number of integral solutions for that, and then we'll try to find out the answer for the required question. So suppose a plus b is less than 41 is given to us, and say a is greater than or equal to 0 and b is greater than or equal to 0. The whole point is that because of modulus, the number of solutions that we have for the required equation will be some way related to the question that we are trying to solve over here. So let us try to answer this. A plus b is less than 41. So if a is equal to 0 and b is equal to 0, this is one solution. Similarly, if say a is equal to 0 and if b is strictly greater than 0, how many solutions does this have? B can be either 1 or 2 or 3 or dot 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 till 40. So this will have 40 solutions. Similarly, if say a is greater than 0 and if b also is greater than 0, then how many solutions will this have? Then this becomes equal to a plus b is less than 41. Because a and b are non-negative integers, we can assume that a plus b will be less than or equal to 40. So now let us add a new variable, which is a plus b plus c will be equal to 40, such that c is a natural number which is greater than or equal to 0. Because you know that sum of a plus b is less than or equal to 40, it would imply that there exists a new variable c, which is again a non-negative integer, such that the sum of a plus b plus c is equal to 40. Now again remember that a and b are strictly greater than 0. So let us assume that a is equal to a1 plus 1 and b is equal to b1 plus 1, such that now a1, b1 and c, all of them are greater than or equal to 0. So the required equation or the given equation will transform into a1 plus b1 plus c is equal to 38, and all the three variables a1, b1 and c are now non-negative integers. We know the solution for the number of solutions this equation will have. You know the formula that if there are x1, x2 plus dot 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 plus xr, if there are r variables, all of them are non-negative integers, that is they are whole numbers, they can be 0 or 1 or 2 or any of those numbers, and if they equal n, the number of solutions of this equation will be equal to n plus r minus 1 c r minus 1. That is the whole point of converting a into a1 plus 1 and b into b1 plus 1, because we want all the three variables on the left hand side to be non-negative integers. We don't want any additional restrictions that they should be greater than 1 or they should be greater than or equal to 2. We don't want any of that. So now how many solutions does this have, which is a1 plus b1 plus c is equal to 38. We have three variables and they sum up to 38. So the number of solutions will be 38 plus 3 minus 1, that is 2. C3 minus 1, that is also equal to 2. So this is 40C2. The value of 40C2 is equal to 780. So in the case where a is greater than 0 and b is greater than 0, the number of solutions is 780. This is for the simple inequality that we assumed, that is a plus b is less than 41 and both a and b are greater than or equal to 0. But the given equation doesn't say that p and q are greater than or equal to 0. P can be less than 0, P can be 0 or P can be greater than 0. But whatever we have found over here, we'll try to transform that using symmetry. Now if you're looking at it from the standpoint of P, the number of solutions where P is equal to 0 and Q is equal to 0 will remain the same. You'll have one solution for that. But now when you have P to be equal to 0 and Q to be not equal to 0, how many solutions does this have? This will have a total of 80 solutions. Because when b is greater than 0, we have 40 solutions. We'll have the exact same solutions when b is less than 0 also. So the total will be equal to 80. Similarly, the other way around, where p is not equal to 0 and q is equal to 0, the number of solutions will also be equal to exactly 80. Now for the last part, where p is not equal to 0 and q is not equal to 0, How many solutions will that have? It will have 780 into 4, because now we'll have to consider two cases. Earlier we assumed that A is greater than 0 and B is greater than 0. Now A can be less than 0 and B can be greater than 0, or A can be less than 0 and B can be less than 0, or A can be greater than 0 and B can be less than 0. In each of these four cases there will be 780 solutions. So the total will be 780 into 4. So if you are totaling up the total number of solutions for this, it will be 1 plus 80 plus 80, and 780 into 4 is equal to 3120. So the total will be 3120 plus 80, which is 3200, plus 80, which is 3280, plus 1, which is equal to 3281. So the required answer is 3281.